Welcome to the IPv6 Buzz, where we dare to dive into the 128-bit address space wormhole. I'm Ed Horley.
And I'm Nick Baralio. We discuss everything IPv6 on the show, from strategy, design, deployment, operations, and even internet standards.
And I'm Tom Coffeen. We've spent 20 plus years working with the IPv6 protocol. We work on getting IPv6 working.
And we're here to share some lessons learned and how to avoid common mistakes.
Hey, thanks for joining us on the IPv6 Buzz. Today we've got an IPv6 Basics episode lined up for folks, and we're going to talk a little bit about deployment at a high level, kind of the why, the what, the where and how, and the when of it. Ed Horley is traveling today, but I'm here with co-host Nick Baralio. Nick, how are you doing today?
Doing well. Just recovering from whirlwind IETF 123 meeting.
Yeah, you're over in Madrid, right?
Yes, eating all the good food.
Hey, nice. International man of mystery, Nick Baralio.
More like an idiot abroad.
I'm sure you hold your own.
I pretend.
So I guess we'll start off with the sort of the why of deployment, which, I think for folks that have been messing around with IPv6 a little longer, this is not so much of a question anymore. We've been banging our heads against the IPv6 wall for quite a number of decades at this point. But if you're new to the IPv6 game, why is it that we're deploying in the first place? And what would your response to that question be, Nick?
I think for me, it would be a couple of different points. The first one would be for securing what my future network is going to look like, and making the jump to the current internet protocol so that I don't have to hurry and do it in a rush later. I'd rather have it started, kind of understand what I'm doing, and be able to sort of control my pace.
Yeah.
And that's how I like to do pretty much everything. And this is really no different. It's a pragmatic approach, right? This is the current standard. If you look at the trends especially over the last 5 years, everything is sort of trending this direction from a content perspective, from a support perspective. It just makes sense to get started. And I don't want to have it be a fire later.
Right. Well, and kind of inherent in what you're saying is the fact that it's not something that you can just turn on overnight. This is for most organizations, for all organizations, enterprises, et cetera, it's a large cross-functional IT initiative that adopting IPv6 sort of represents. So, it's not a scenario where it's like, well, I could just flip the switch and it's on. Of course, it's already running by default on operating systems. So then the question becomes, are you really managing it effectively? Have you tracked the way that it's already sort of seeped into the network? But your larger point about it being something that you want to manage, we sort of make that argument to a lot of enterprises that it can be really more about risk management initially, where, to your point, having to deploy it in a very deliberate way that gives you the opportunity to do it in a very controlled fashion and not have to try to rush and do it overnight. For a lot of organizations, that represents a significant amount of risk to their operations, to the costs associated with their operations. And so, really getting a handle on, starting IPv6 deployment sooner than later is pretty critical, I think.
Yeah, I would absolutely agree with that. And I know that, I'm dating myself here, but, when the time came to start turning off, what were at the time stereotypical enterprise protocols, like IPX was the big one, right? When we went to disable that, the internet and IP wasn't nearly as well known as it is now. So everybody spent the time to learn it. Most people knew IPX, SPX well enough to sort of run their file servers and all those things. And to a lesser extent, protocols like AppleTalk and DECnet and those things existed as well. But when you move from one sort of pervasive thing to another, you need to understand what the quote unquote other is before you do it. And so that's a long tail. Like you said, that's a strategic move that is often a cross-functional, long-lived project within any organization. Doesn't matter if it's a service provider or an enterprise or whatever. It doesn't really matter. It's a big deal to sort of change the chassis out, while the car is running.
That's right.
And so the sooner you get started on really just understanding it,
yeah,
the safer you are and the less risk that you're going to have later on down the path, because you never want to jump out of the airplane not understanding how the parachute works. Although I say that I do that all the time, that's mostly in jest. I tend to be fairly pragmatic.
Right.
And I want to know those things. And I think this is really just an extension of understanding long-term trends in the discipline that you're in.
Yeah, that's right. And the reality is for most organizations, they're already so resource constrained in terms of IP addressing that's available. It's like, well, we always relied on NAT and, we're overloading NAT and taking, a lot of advantage of the private address ranges. But I don't think there's a, larger enterprise around that hasn't run into this scenario where they've got multiple overlapping private IPv4 space that, severely restricts, whether they're recognizing it or not at the time, severely restricts the architectural flexibility that they have overall within the network. And so to your point about, getting it out there and starting to use it sooner than later, just so you can manage it more effectively, there's a sort of virtuous cycle that you can get into where you have other initiatives in the enterprise that are required. And some of it's like just basic tech refresh stuff. Some of it might be, moving from one architecture to another, going from a distributed, core distribution access sort of sandwich model to EVPN, VXLAN, leaf spine sort of architecture. You may have that initiative lined up without having thought about where IPv6 fits into that picture. And there could be any number of those initiatives sort of architecturally that are cropping up where if you are thinking about IPv6 proactively as you engage in that initiative, there's like a, dual benefit of you may be taking advantage of architectures that are just not feasible in IPv4, using an IPv6 underlay as an example, but you're also improving your facility overall operationally with IPv6 that allows you to have more mastery in other areas of the network where you might be tackling different architectural initiatives.
Yeah, I mean, and that's absolutely right. I mean, there's so many advantages to the flexibility that it provides that it would just be, it would be a disservice, even if you never end up doing it, which I would assert is unlikely. Investigating the options and the advantages that it provides is, if you don't do that, you're doing, the royal you or whatever is doing a disservice to the organization because you're just not looking at all the pieces of the puzzle. You will end up doing it eventually, unless you are going to retire in the next 5 years or so, 5 to 8 years. You're going to do it. I mean, you're going to have to learn it. Personally, I would rather learn something on my own schedule than be forced to sort of maybe understand the basics and just kind of throw it together, right?
Yeah.
And there's also, I would argue that there is a security advantage to IPv6 deployments if for no other reason that it isn't easily scannable. I'm not going to say it's not scannable, but the majority of the security issues that are going to be sort of opportunistically pointed at systems that typically run inside of an enterprise are going to be IPv4 focused. And I've seen the data on this because I've seen large scale black hole, tar pit data. It's almost exclusively IPv4. And when it is IPv6, it's one of two things. It's just opportunistic. There's a quad A record and the host on the other side happens to be dual stacked.
Right.
And that's another good data point. That's trending up a little bit because there is more IPv6 deployed out there. And then the other advantage is that it really isn't scannable. And so those types of things they kind of change the conversation. I don't want to say they solve all the problems because obviously they don't, but when the conversation gets shifted to, I don't necessarily have to worry about anything other than maybe drive-by stuff where it's like embedded in ads and things like that. And you really solve that at a higher layer than the network layer. The underlying protocol doesn't matter. And those are much more common, I think, than sort of the opportunistic things. And then, you have the targeted attacks, right? It doesn't matter what the protocol is. If it's sophisticated nation state stuff, they're going to have the resources to know all the things anyway. So just the simple advantage of moving off of this legacy protocol that we all think we know really well, but at the end of the day, how many organizations are doing diligent forensics on all of their traffic? I would assert that that number is pretty small and that what they do instead is just create ACLs that give them a false sense of security or firewall rules or whatever.
Yeah, what percentage of avowed security is actually just that? Who knows? To your point, as far as the space not being scannable, I mean, there's just for the folks that are sort of newer to IPv6, there are a lot of security myths that sort of float around out there related to V6. And one of the ones that escaped the lab pretty early on was the idea that V6 is somehow inherently more secure.
Yeah, I guess my comment is more towards it's that first order security that everyone always waves their hands about. I'm closed off, right?
Exactly. The perimeter.
I'm protected, but that's not really the case in most cases, right? Because drive-by attacks are pretty common and no protocol is going to protect you from that. That's an application layer.
Exactly.
But I do think that, especially when you move into the V6 only space, which, is probably phase 3, right?
Right.
Phase 1 is, understand V6. Phase 2 is deploy dual stack and IPv6 mostly, and then move to IPv6 only. But you gain the simplicity of managing one protocol that does have a lot more flexibility than the one that you've disabled.
Yeah, and that's really, I think, the key to the why deploy question, at least from my perspective. We talk a lot about technical debt, and we've accumulated a ton of technical debt where IPv4 is concerned. Obviously, NAT comes in for a lot of criticism based on the fact that there are aspects of it that we don't recognize on a regular basis as being impactful to network performance or architectural flexibility. We've got NAT stacked on top of NAT in many cases, but the reality is that kind of technical debt, there's the opposite of it, a kind of what I don't know, we call a technical credit that you're instilling into the network by adopting IPv6, that virtually unlimited addressing and prefix space that's going to give you so much more architectural flexibility in the future that all the engineers that come after you will thank you, hopefully not curse you. It's like you've given us a lot of flexibility here with virtually unlimited addressing, and of course at some point it'll just become the norm when everything is IPv6 only. We'll have discovered all mountains of other forms of technical debt that we'll be laboring under, but it won't involve addressing resources. So maybe to switch gears and pivot a little bit to the next question of that's the sort of why of deployment. So what do we really need prior to getting started? And I'll go ahead and throw out my answer to that, which is like of course what I'm going to say, and anyone could guess this is true if they've looked at my CV, but a large enough IPv6 prefix, from a regional internet registry, a provider independent prefix, meaning, it's portable space that your organization can use and take with you and route through any provider. And an address plan to go along with that, I think I don't know if you would agree with me, Nick, but maybe is that something that you would consider essential prior to any sort of IPv6 deployment?
Yeah, for sure. I mean, before you're going to deploy it, you need to know where.
Yeah.
And you kind of need to know how. So I've done it when I was first learning, just sort of throwing things at the wall to see, where I could configure it and where it would work. And I always ended up going back and had to clean it up and whatever. So having a good plan that's probably the number one priority in my mind, is like, just let's have a good plan, right? With the expectation that it is flexible enough that you may need to adjust it a little bit, right? Because we all know that's going to happen, right? It needs to be built in a flexible manner.
Yeah, that's right. And I think one of the areas of that flexibility where you initially sort of confront this related to what I mentioned just a moment ago about getting a large enough IPv6 allocation, a large enough, provider independent prefix to use for your network, and kind of, if you're new to IPv6, if it's something that you haven't looked at before, the question of how large is large enough, and the way in which we go about answering that question based on our knowledge and experience working with IPv4 versus recognizing how IPv6 generally gets handed out in terms of prefix sizes and for sites and subnets, and so you can kind of shoot yourself in the foot right away, bringing all of your IPv4 assumptions that you're going to just subnet the heck out of everything and do what you have to do in IPv4. You're going to take the same approach in IPv6 because you don't want to run out of IPv6 address space.
Yeah, I like to challenge people to think, what are all the things that I don't like about how I've done my IPv4 allocation? Like, what are problems that I could do without? What are the pain points with this? And some of those things are so ingrained that people don't really even know. They're just business as usual, right? But if you really force them to think about, like, man, I really don't like having to sort of limit, oh, I only have a /27, but it's in this block and that's summarized over here, but I need, these and these and these things. That's just become the norm.
Yeah.
In my experience for V4 is like, you just, even with private space, unless you have this like incredibly regimented procedure for doing your addressing, which I would assert is probably maybe 20% of medium and large environments, that's a shortcoming. Like, I don't want to have to do that anymore. Like, I want to be able to say, I have this block and I can take what I need out of it and I don't need to worry about it, because that brings me to my second point is, in my opinion, it's not about solving the today problem, because there's enough runway and there's so much address space that you can start looking. And this is hard for some people, especially highly technical people that want to look at tactical problems. Like this is a strategic thing. If you look at it, you can say, what might this look like in 10 years or in 15 years or in 20 years? I don't want to need to do this for 20 years. Like, let me ask for what I might need then, because even that request, as foreign and as difficult as it may be to sort of grind your mind around, is that if you ask for what you're going to need in 20 years, that's still a very reasonable request for your IRR. They're really probably not going to care because the addressing space is so vast.
Yeah.
And that's a very hard problem to get people's minds around.
Yeah, absolutely. And getting them to think more long term and recognizing that there's no authority that is limiting their access to those address resources upfront. And that's not the mindset that most people bring in based on having worked with IPv4 and being so space limited, and thinking in those, as you say, those 10 to 15 to 20 year timeframes is really difficult to do. And maybe it's helpful to know that, not only are the RIRs not interested in policing your IPv6 consumption, prefix and address consumption, they have the opposite problem of wanting to limit the amount, and this is very explicitly stated within their guiding documents, wanting to limit the amount of disaggregation that's occurring in the overall internet. And it makes more sense to give you a larger allocation today that doesn't require you to come back in just a few years to get another separate allocation to cover your address and prefix needs, that then ends up resulting in more prefixes in the global routing table. So they're trying to solve this other larger problem. They're not going to be persnickety about how you're using your prefix and address space. And then, of course, this is the ultimate arbiter of that, is the fact that you look at the availability of and the abundance of address and prefix space, in the standard /32, if that's still the sort of legacy enterprise allocation, that's still 65,000 /48s for sites, and each of the /48 has 65,000 /64s for subnets. So it's just the numbers involved. It's really challenging initially to get your mind around it. But the sooner that you do, the quicker that you'll get to a point where you're really taking advantage of the architectural flexibility that's there, over the 10 and 15 and 20 year timeline, as opposed to just, what's going to work next week.
Yeah, I mean, I think that, you mentioned technical debt earlier, and so many IT shops are just drowning in technical debt because there's so much to do. It's a utility, so, it's like the electricity. You have to be careful when you do things on it. So everything just takes forever to do. I think we all can kind of identify with that problem. And so if you think about the technical debt as, this is something I don't like. Nobody likes technical debt. It stinks, right? It's no fun. It's like, it's not shiny. There's no, it's the toys you already have.
Yeah, that's right.
And so if you look at IPv6 as an opportunity to say, like, here's these problems that I have with my addressing, I don't like them. I'll just ask for, a 32, that's the default, right? That's very easy to get. Like, you don't have to do anything except for say, I want some v6, and they'll give you a 32. But 32 may be okay for the next 5 years. You never know. You might start deploying prefix per host. You might start doing, /48 per Kubernetes cluster. Those things that's happening now.
It's real stuff. Yeah.
It's real stuff. And, when you want to think about the hierarchical deployment, it's like, well, maybe I need a 28.
Exactly.
Or whatever, right? They're just going to say, okay, show us what your plan is. And you give them a rough plan of what you want to do that's sane, and they'll go, all right, there you go. And then that's it. They don't want to police it. You're totally right. They want progress, and they don't want disaggregation.
Yep.
The result of that is you can get what you need. You can get what you need for 15 years from now, Nick, or whatever.
Exactly. I mean, what else do we need to cover as far as what is needed prior to deployment? I mean, I know there may be a big question mark over folks that are new to IPv6 about whether or not their gear, their hardware and software is going to support IPv6 and to what degree, knowing that it's like the vendor's going to say, oh yeah, no problem. It supports IPv6. Just turn it on. It'll all work, and of course the bitter tears that we've wept having heard that and struggled through the opposite of that happening. over the years. But, for folks that are new to it, I mean, I guess I would start off with the assertion that in general, there's a tremendous, support, if it's not total feature parity with IPv4, the functional parity, across a lot of platforms is just, you've got almost a late adopter's advantage in that regard, that there's a lot of great vendor support that wasn't around like 10, 15 years ago. So I guess I would start with, I would want to make sure that we include that necessity of assessing the current environment with that caveat that, there's a lot of stuff that supports it. But what's your take on that, Nick?
Know your network, first of all, know what's on it, know what's, running it. So, understand what you have. Now, when we started working on, the IPv6 only initiatives that I've been working on, that was phase one. Just figure out what's there. Because if you don't know what's there and you start you don't want to start loading things onto a boat with holes in it.
Right.
It's like, I got to understand what is currently out there and then figure out what I'm going to need to replace. And that's going to change constantly, right? Because like you said, sure, we support it, but I've run into products that aren't tested in a V6 only environment. You can turn V6 on, but they complain when there's no V4 or they may not work at all. So that leads me to one thing that I am extremely vocal about, and that's with the understanding that I know that this is just not feasible for some organizations that are small and don't have budget. But if you can manage some kind of testing environment, your life is going to be much better, because then you can sort of control the conversation, enable things, and test them yourself, and make sure that they do work. And you can sort of rely on vendors for some of these things, but it's never going to get you all the way across the finish line. You're going to have to do some of that legwork yourself.
So you're saying a proof of concept network, essentially?
Yeah, I mean, if nothing else, plumb yourself a network that has the attributes that you want, that you will operate on as a daily driver, and just see what doesn't work. That's sort of the lowest bar, in my opinion, is, eat your own dog food first. And that way you can sort of document the things that you're going to have to look deeper into, and it will make deploying to friendly users a lot more pleasant for them.
Right.
Because you've already done the first level troubleshooting and figuring out what doesn't work. And again, I think that a lot of these things, especially on the software side, are going to be late adopter advantage is a great term, because now that CLAT is available nearly everywhere, and soon to be, I think, everywhere, that's going to be a watershed moment when it comes to deploying in legacy environments like enterprises, where there's probably old software applications. They maybe do IPv4 literals, or they just don't have any notion of IPv6. When CLAT is enabled, it doesn't care. They won't care because they won't know.
Doesn't matter. Yeah, that's right.
But yeah, the lab and eating your own dog food as far as testing on yourself, I think is, I don't know. I like those methodologies. They've worked for me. I don't know that they'll work for everybody. Obviously, not everybody's the same, but that's what works for me.
From there, I guess we get into where and how deployment should start. Once you've got your sort of understanding of what's needed prior to deployment that we talked through a little bit, like taking that first step, and some of that, as you say, might just be, enabling it where you're familiar with how things should normally operate. And that could just be your desktop, your local LAN segment, subjecting your cubicle mates to IPv6 and sort of seeing where you end up with that. But as far as the more formal overall high level of adoption that we're sort of talking about, it's like, I'm at an enterprise and I know we need to do this. And I know it's a big cross-functional initiative. And it's like, where in the network do I start doing this, as an example? Like back in the day, the classic start in the core of the network. And that was something that you had control over, that it's constrained in terms of the boundaries. You in general had, back in the day, you had robust support initially more for, some of the routing protocols. It may not have been the same level of support out to the desktop edge, so then from your perspective, does that model still hold these days, where, you start, because there's like one of two approaches: starting from the inside and working your way out, starting from the inside being the core and sort of working your way out to the internet edge or down to the desktop edge, or taking the opposite approach, like say enabling IPv6 in your internet edge DMZ as an example, and getting that connectivity turned up. Is that the way to go? And then like bleeding back into the core, or is it, do all the things at once? What do you think? What's your opinion?
So I like the model of starting at the outside because you have to make sure you have V6 transit.
Right.
I mean, none of this is going to work unless you can transit it outside of your network. So plumbing it into maybe the DMZ or up to your border routers, to me, is sort of phase zero, because if you don't have that, you can't start.
Got it.
I mean, I guess you can and you can tunnel it, but nobody's going to want to do that. So build it there. And then I like to build out from the core, because the core networking is, like you said, that's tried and true. That's been around for 15 years. It just kind of works.
Right.
And you have to build the road before you can drive on it anyway. So, with the exception that you're kind of building the off ramp first and then building the road. And then I like to plumb it down to, like I said, myself, to make sure that it will work. And then I just run like that for a while and then just expand it from there. But different organizations are going to have different, they may want to push it to their servers first.
Mm-hmm.
I mean, that's how some federal mandates work. Like, you have to build it to your edge. You have to put like your mail server on it, and you have to have a web server enabled on it. That was what, 2012, 2009, something like that, when that was mandated for federal agencies. And most of them did that and then just stopped, right? Because the hardware support wasn't there, and
Yeah.
software support. But if you do it in that sort of controlled manner in the layers, then I think that makes for a much better experience. I'm sure there are other ways to do it. Those are the ways that I've done it.
Yeah.
They're very pragmatic, I guess, is the way I look at them.
Yeah, and that's sort of, I guess, an exercise left for the listener, that you know your environment better than we would, and the sort of general assertion that outside in is best or inside out is best. It's going to vary depending on your particular situation. So you may not feel like you have enough of a basis of understanding with IPv6 to make that sort of choice or decision. And so it sort of brings up the question of training. Where into this question of deployment does training fit in? What is the timing for the IPv6 training? If it's something that you can have access to in terms of formal training that somebody can, as a training provider, besides the stuff that you're doing on your own and the ways that you're exploring and understanding IPv6 on your own, do you feel like training plays a role?
Oh, hugely.
Yeah.
When I got started, there wasn't any. And probably you're the same, right?
Yeah.
There wasn't a whole lot out there. You could maybe find some textbooks that mentioned IPv6. But now there's lots of training options. And I think that's really important, especially for some people. Like, there's people that like to learn by doing and breaking and then fixing. And then there's people that like a formal, like, I want to understand the fundamentals. And I do think that there is a pretty serious advantage to taking fundamental courses that will illustrate the things that aren't often spoken of, that will help the engineers and the implementers understand that those really kind of base pieces, like if your host has IPv6, it will use that first.
Right.
And if it has IPv4, like, just those really simple things that probably I take for granted. I know I take them for granted because I've been doing it a long time.
Yeah.
There's a lot of people that just don't know those things. That doesn't even occur, right? Because why would it? They've only ever used IPv4. I think that having the training is really, really important, and having options to do that early and often is, for some people, that's the way to do it.
Yeah, I really agree. The timing of training, I guess, it's like, should we do it sooner? Should we do it later? I think it should really be ongoing for most organizations. And this is part of the challenge with any large cross-functional IT initiative, where the time frame for deploying it is so long that by the time the middle part of the project or the final part of the project kicks in, everything that was trained on for the initial part of the project has long been forgotten by folks that may be new to the organization. They may not have had any of that training, and so you do really run into that problem where you need to do it initially so that the core team understands, as you say, like, enough of the internals of the protocol that they're not just immediately shooting themselves in the foot. But if on a long enough timeline, all that training is going to have to be repeated at some point. And then it becomes a question of, figuring out who the folks are that need what variety of training to really, make sure that they're on top of what they need to be on top of for the project and getting it moving forward.
Another thing that I like to do is couple a network engineer with, say, Unix admin, because they're going to have vastly different perspectives on what the training is going to provide them. And they're very often complementary, right? Because the network engineer is going to understand probably more of the base protocol pieces and how it moves around and what the paths are supposed to look like. And they're going to understand MTU and other, path MTU discovery and things like that. And they may understand things like multi-topology and stuff that the systems folks may or may not. I mean, that's generally out of scope for a lot of like systems folks because they're focused on how the host behaves.
Right.
And if you put those things together, then it's like chocolate and peanut butter. They're just very complementary, right? Because they'll give each other feedback. I mean, I've seen this also not work well, but in general, when you have people that want to be there and they want to learn, they'll share their experience and information and what their expectations are. And so, you have a Unix admin or a server admin of some kind. And if you're really lucky, you can throw a developer in there too, although that's maybe stretch goal. Then the expectation levels go from all over the place to they're more closely aligned. And I think that just makes for an overall better long-term experience because when expectations are set and aligned, or at least in the same book, then there's no surprises, and surprises tend to irritate, highly technical people. So if you can couple those things together, I've had a lot of great experience with that.
Yeah, I think that's an excellent recommendation. It's sort of cross-pollination across functional silos. Yeah. And with any luck, you get a virtuous cycle out of that with folks reinforcing their interest in IPv6 by understanding how it's working outside of their particular domain and seeing the integration points, which of course, probably most critically is the reality of, I've got to have a bunch of configuration on my router interface in order for hosts to get the information that they need. And so if you're sort of new to that, then that's definitely something where teams working together on that and understanding the interdependencies is really helpful and critical for success.
Yep.
Yeah, all right. Well, I hope, this is ostensibly an IPv6 Basics episode. I think we've covered a lot of good ground about deployment. Is there anything else that we've left out that we need to make sure we cover before we bid adieu to the listeners today?
No, I think that's a whole lot of stuff.
Yeah, a whole lot of stuff. Hopefully there's some useful information in there for folks, and we'll definitely be back soon with more IPv6 Basics.
Yes, indeed.
Thanks for joining us for this episode of IPv6 Buzz. If you've got feedback or follow-up on this topic, send us a message at packetpushers.net/FU, where FU stands for follow-up. We'd love to hear from you and continue the conversation.
Also, at packetpushers.net, you'll find a range of other deep dive technical podcasts for IT pros.
There's a whole lot more on the Packet Pushers site as well, such as tutorial videos and a community Slack channel where you can talk with industry peers and experts. So whether you're deep in your career or just starting up, Packet Pushers is the place to go to grow both your skills and your personal network.
So long and until next time, we'll see you on the IPv6 internet.